This is a gate practice problem on operational amplifier. So the question is that we have to find out the output voltage V0 and the current that flows through this load resistance of 20 kilo ohm, and we have to consider that the op amp is an ideal operational amplifier. So with a question like this, our approach has always been to look at the fact that because virtual short exists, and this is due to the fact that there is presence of negative feedback, and then we are also aware of this information that the voltage applied to the non-inverting input terminal is plus 5 volt. We can easily write down the voltage at the inverting input terminal node. So this is that node, and because of virtual short, this voltage will also be at 5 volts. Now once this is set, we have a current of 0.1 milliampere. So here is a constant current source, and so this 0.1 milliampere is driven through this branch. Now note that because this is an ideal op amp, again it's a repetition of our understanding that an ideal op amp does not draw any current through its input terminals. So whatever current that is flowing through this branch, which is equal to 0.1 milliampere, the entire current will flow through this 10 kilo ohm resistance. And the input terminal of the op amp offers infinite input resistance, and therefore you have zero current entering the input terminal of the op amp. So because this current is 0.1 milliampere, and we already know this node voltage as 5 volt, the other end is at V0 volts. Therefore, we can apply Ohm's law, and we can write that this 0.1 milliampere is equal to 5 volt minus of V0 divided by 10 kilo ohms. And so instead of writing kilo ohms and milliamperes, which will either way cancel each other, so we can formulate the equation as 5 minus V0 divided by 10 is equal to 0.1. And proceeding with this little algebra, we find that V0 is equal to 4 volts. So the output voltage is equal to 4 volts. And then if we have to find out this load current IL, again we apply Ohm's law, and we know that this current IL is equal to V0 minus of 0 divided by 20 kilo ohms. And so IL can be written as 4 minus of 0 by 20 kilo ohms, where we had already obtained the value of V0 as 4 volt. So from here we obtain the value of IL, which is equal to 0.2 milliampere. Now just going one step forward with this problem, see that here was the current of 0.1 milliampere which was flowing through this feedback resistance, and then the load current was equal to 0.2 milliamperes, and therefore the additional 0.1 milliampere must be contributed by this operational amplifier. So this op amp is sourcing 0.1 milliampere, and so this 0.1 plus the 0.1 obtained from the operational amplifier's output results in the load current of 0.2 milliampere.